Okay, we're going to look at the homework on counting first. And this we need My Open Math. Back to section 2. Here is the counting part that we already did, and the counting homework. And if you've done all of this,
there were a few I got stuck on.
yeah, okay, that's what we'll fix. The first one is, what's the value of 12 factorial? 12 times 11 times 10. You put it in Excel, FACT 12. Equals FACT 12 factorial. And that's 47, 4. It's a big number that starts in 479. So there's a big number that starts in 479. That's 12 factorial. Stick it in Excel. This next one is permutations. Permutations are, this case, 3 things taken from 11. So it's 11 things taken 3 at a time, and order matters. Permutation, order matters. ABC is not the same as CBA. This one is the permute command. Equals PERM, and it comes up permute. The number, which in this case is 11, and your homework is going to look different. It's got different numbers. Mine's going to be 11 and 3. 3 things taken out of 11. And 990. And there is 990 on mine. Combinations. What's the difference between combinations and permutations? Order matters. Permutations, ABC is not equal to CBA. Combinations, order doesn't matter. ABC is CBA and all the other possibilities. Right, we have in this one exactly the same numbers, 11 and 3. I don't know whether that was in by design. Does yours come out that way? One's 11 and 3. The combinations is 11 and 3. Oh, yours didn't have. It's not built in then. Equals. And if you ever forget, start to spell it. Combinations, 11 and 3 in this case. And there are 165 ways to take 3 things from 11 when order doesn't matter. So the difference between these 2 things is the number of things that are repeated except for order. May as well. We got 9 books in the Judy Moody series. I guess this is a clever pun or something. How many ways can we put them on the bookshelf? How many ways can you put up the first book? 9 books? 9 choices? You put the first book up. How many books you got left? You got 8. This is 9 times 8 times 7 times 6 times 5, because we have to place all of them. So this is a factorial. Equals FACT. 9 out. And I get I never can do these numbers. 362880, you ought to have a similar number. And there's the answer. This one, we have pizza, 4 types of crust, 5 types of cheese, 5 meat toppings, and 4 vegetable toppings. Why would you put vegetables on a pizza? Personal preference. How many different pizzas can we have? How many types of crust? Whatever you got. This one is 4. There's 4 possibilities. 5 types of cheese. Any one of the 5 can go on any one of the 4 types of pizza crust. So this is 4 times 5 times 5 times 4, however many that is. And these things are probabilities. They're counting. This is counting again. The letters in the word mathematics are arranged randomly. What is the probability that the first letter is E? Basically, how many letters are there in mathematics in the word? 11. How many can start with E? 1. 1 out of 11. The letter M, they got clever here. There's 2 M's. So it's 2 out of 11. Eight colors, and we want a flag with 2 vertical stripes, all of different colors. Basically, is this combinations or permutations? Does order matter? Order doesn't matter. Repeats aren't allowed. So, what have we got here? This is still combinations. We have 8 colors. We want 2 of them that are different. So AB is the same as BA. We want different colors. This is combinations, and it's just going to be 8 combinations 2. 2 things taken 8 at a time. There's another one. Here's another kind of counting. A true-false test contains 17 questions. And how many different ways can this test be completed? How many choices do you have on a single question? 2. How many times can you do that? 17 times. This is just 2 to the 17th. And 2 to the 17th is equals 2 raised to the 17th power. 131072. Hopefully that's the correct answer. 131072. These are all different versions of permutations and combinations. Combinations and permutations kind of fall out of these things. So basically, it's how many ways can this thing go here, what follows it, and can it be the same? Here's more letters. That's the end of that one. Look at the binomial homework. Binomial probabilities. The first one here, you got a first one like this, just different numbers. Okay, so we're talking about the same thing. N trials, what's the probability of exactly 5 successes? This is the binom.dist with 5 successes, 6 trials with a probability of 0.5, and it is individual, exactly 0.5. And this is the probability that x equals 5, exactly 5. So that makes it an individual probability. This is the same thing, different numbers, the probability of exactly 6. So you use a 0 at the end. Here, the probability that x is less than or equal to 3. 3, 2, 1, and 0. This is cumulative with 6 trials, probability of success of 0.5, with 0, 1, 2, or 3. You can do them individually and add them up, or use the 1. Binom.dist, 3 or fewer successes, 3 is first, 6 trials, 0.05, and then the 1 for cumulative. Another one. Here, this is 4 or more. What's the easiest way to do 4 or more? Get the other side and subtract. Get 3 or less, because there's a command for it. You've got that 1, and it will do 3 or less, then subtract it from 1. So that goes the other side. This is the only thing in Excel that is actually a problem. Excel does everything from the left, from the low side. And when we do normal, it's going to always be from the low side up. So this is from 4 up. It's easiest to do from 0 to 3 and subtract 1. And that's another one of the same thing. This is a trick question. If a seed is planted, it has a 70% chance of growing into a healthy plant. Birds will sing, butterflies will fly. If 7 seeds are planted, what is the probability that exactly 4 don't grow? What's the hitch in this? What's the probability of growing into a healthy plant? 70%. 70%, 0.7. What's a success? Don't grow. This is the probability of failure. The probability of success is 0.3. So we want a 0.3 chance. 7 seeds, 7 trials, exactly 4, and the probability of success is 0.3. Binom.dist, we have exactly 4 successes out of 7 trials, and the probability of success is 0.3. The probability of failure is getting a healthy plant. Right? The binomial isn't always straightforward. This goes back to looking at epidemiology. What's the probability of getting Ebola? Getting Ebola is a success. So this one is just the opposite side, and it's exact. 0.097241, 0.097. Oh, good, it worked. 0.097. This one, this is something that really doesn't come up very often. What's the mean of a binomial distribution? We've got a number of trials and we have a number of successes. The mean is the number of trials times the probability of success. The number of trials times the probability of success. So in this thing, about 1% has a particular genetic mutation. 100 people are selected. Find the mean. It's just 100 times 0.01. So the mean is literally 1. Right? The binomial is ones and zeros. If you took in this one and you put 99 zeros and 1 in a long string and use the average command, you will get 0.1 times 100. In the binomial, because it's zeros and ones, it's a simplified version of the things with other numbers. So if we can get the average of a string of numbers that aren't zeros and ones, with the average command, we can get the same thing with the binomial. The binomial is a piece over here of a huge bunch of distributions that have different characteristics, but they are all common in the things that you can calculate from them. This is average. You ever see anything you couldn't calculate an average for, at least that was numbers? Doesn't matter what it is. Zeros and ones are the simplified version. And this is more of that, a share of 24. 24% of sets were tuned to Pretty Betty. I like Ghost. It was on last night. You see Ghost? That's funny. And I can't imagine the people acting in this show. Here's the guy who can't see Ghost and his wife who can see Ghost, and all these people are standing around being Ghost, and this guy has got to ignore everybody. Right? That's acting. This is the same stuff. 24% is the probability of success. We have 11 households. That's the sample size. 0.24 is the probability of success. And all of these things are just how many successes. This is 0, at least 1. 0 and 1, it's cumulative. At most 1. You take the other side. And so all of these things are common, and they're based on basically 2 commands. So that's the binomial homework. You can do that one now. As if you couldn't do it before. You could do it before, most of it anyway. So watch the success. What is a success in the binomial? What's the probability? And once you've got those 2 things, then it's just which command are you going to use. Put a 0 or a 1 at the end of it. Okay. Any questions? All right, go away. Flee. Run screaming from the room.